Welcome back, dear students. So, this is Lux School of Science and Chemistry is welcoming you back. I'm Farid and we are going to study lesson number 3, Electrochemistry, part 5. Up to this, we have studied about the cell potential and EMF. Okay, now today we are going to find out the standard value and non-standard value. What is standard value and what is non-standard value? That must be understandable. Okay, so dear students, standard value is on standard condition. Which are the standard condition? So here standard condition is 1 molar concentration, 298 Kelvin temperature and 1 bar is the pressure. Then these values are known as standard value. And on that standard value we have the EMF is also standard. Why I am telling this? I am telling this because you know that 1 mole means how many? 1 mole is nothing but the 6.022 into 10 raised to 23. How many? 6.022 into 10 raised to 23 electron will pass. Okay, and this much electron will give us standard EMF, and that's why this EMF at 1 molar concentration is called as standard. But you know that if there is no concentration of 1 m, if concentration is not 1 m, then what will happen? Different value of concentration is there, then I don't think it pass 6.022 into 10 raised to 23 electron. That is 1 Faraday electron. 6.022 into 10 raised to 23 is 1 Faraday electron. So I don't think it is passing 1 Faraday electron. And that's why we have to change the value. And this kind of EMF, what we will develop is non-standard EMF. Okay, so if temperature and pressures are different, then we will have non-standard EMF, not a standard EMF. Okay, so here what will happen, that we are going to check out. Okay, afterwards what will happen, okay, if the EMF is not standard, then what will be the problem arise? Okay, so dear students, let's study, okay, which problem will be arise there. Okay, so here we have developed one relation, that is the first the standard values representation. So how the standard values will be represented, that we are going to study first. So see here, okay, standard value of factors are remaining standard. Yeah, while in simple any values of the factors, here factor means what we will say factors are, first factor was temperature 298, here any temperature, then concentration, here 1 molar concentration, and here anything. So like this we will have different value of temperature and concentration, as well as pressure always remains same, also temperature remains same, but sometime it can be changed. Now check out this, what is the, so here representation. So onwards we have represented as Zn by Zn plus 2, but today I am writing their concentration also in bracket. The concentration of Zn plus 2 is 1 molar. Okay, see this, the concentration of Zn plus 2 is written here 1 molar. Same thing, the concentration of copper is also 1 molar. So simple, this Daniell cell now is converted into standard cell because we have taken 1 molar. But if we go about that simple standard, see the concentration is now not 1 molar. Now concentration is changed. I have written there x molar, as well as concentration of copper is also I have changed y molar. So different concentration and the different answer will be there. So we have to remember that in ganglionic cell, if it has standard value, then standard value is 1.1 volt, but if the concentration are changed, we will have some different value. Okay, so now what difference value and how that will be determined, that we are going to check, and that is nothing but the new relation our, and that new relation is very interesting, okay, to understand. Check out that new relation. here. That is known as Nernst equation. Okay. So to determine the standard value of cell potential having anode parallel cathode system, that is the anode and cathode we have used with the salt bridge, then the standard potential is E degree cell is equals to E degree right minus E degree left that we have studied. Okay. Now E degree cell is equals to always right side remaining cathode and always left side remaining anodes, and that's we are going to take E degree cell is equals to E degree cathode minus E degree anode. Now onwards remember this equation, because this is the most important. Here we will take always left side E degree cathode. Okay. And anode, cathode minus anode is the simple way to understand, and cathode remain in right side and anode is remaining in left side. Here you can see the standard. Here you can watch out this degree. This degree means nothing but the standard value, and that standard value is there. Now if there is no standard value, then the concentration of the anode and cathode will be changed. Now if the concentration of anode and cathode will be changed, then which value do they have? So they do have which value that we are going to study. Suppose the value of anode is changed and become A, of cathode is changed and become C. So now that concentration value using this Nernst equation we can take out. So this entire equation is called as Nernst equation. And how you will remember the Nernst equation? E cell is equals to E degree cell minus 0.0592 upon n log anode by cathode. Now how these values come, let's derive this value, and this derivation is also very interesting. So come on dear students, we are going to derive this value, and this value can be derived in the using the thermodynamics. Okay, see here first equation is given that we have written already. E degree 0 is equals to E degree reduction minus E degree oxidation. Okay, that is the cathode minus anode. Cathode reduced out and anode oxidized out. Okay, now in 11th standard in thermodynamics, we have the standard notification of the delta G, that is equals to minus NF cell. Now what is N? N is nothing but the change in the electron. F is Faraday constant. Now you know the value of Faraday constant. Faraday constant is 96500 coulomb per mole. Dear student, ખબર છે ને તમને આ બધું? ગયા વર્ષ જ આવી ગયું છે. ડેલ્ટા G બરાબર માઇનસ NF સેલ છે અને નીચે E પોટેન્શિયલ ડિફરન્સ છે. હવે એને જો સ્ટાન્ડર્ડ વેલ્યુમાં લખવી હોય તો શું લખી શકાય? ડેલ્ટા G ડિગ્રી માઇનસ NFE ડિગ્રી. ઓકે, હવે આ આટલી વેલ્યુ ખબર પડી ગઈ હોય ત્યાર પછી આપણે ચાલીએ કે સ્પોન્ટેનિયસ રિએક્શન અને નોન સ્પોન્ટેનિયસ રિએક્શન માટે આપણે જોઈ શકીએ કે બેનો ડિફરન્સ છે એ બે ડેલ્ટા G અને ડેલ્ટા G ડિગ્રીનો ડિફરન્સ એ ઇક્વેશન નંબર 4 થી આપી શકાય. તો ઇક્વેશન નંબર 4 આપણે લઈ લીધું છે, ડેલ્ટા G ઇઝ ઇક્વલ્સ ટુ માઇનસ ડેલ્ટા G ડિગ્રી પ્લસ RT ln Q. ઓકે, હવે ડેલ્ટા G ના માટે અને ડેલ્ટા G ડિગ્રી માટે આપણે બધા ઉપર સેકન્ડ અને થર્ડ ના વેલ્યુ મૂકી દઈએ તો ફાઇનલ વેલ્યુ આપણા પાસે હશે માઇનસ NFE ઇઝ ઇક્વલ્સ ટુ માઇનસ NFE ડિગ્રી પ્લસ RT ln Q. બધાને NF વડે ડિવાઈડ કરી નાખીએ. અહીંયા આપણા પાસે બધા વેલ્યુમાં NF છે તો આપણે અહીંયા બધી વેલ્યુને કોનાથી ડિવાઈડ કરી નાખી છે? NF થી ડિવાઈડ કરી નાખી છે. તો અગર તમે એને NF થી ડિવાઈડ કરી નાખો તો આપણને આ ટાઈપનું એક ઇક્વેશન મળશે. હવે આ ઇક્વેશનની અંદર what we can go for? તો આ ઇક્વેશનની અંદર હવે આપણે ઇક્વિલિબ્રિયમમાં જતા રહીએ. તો ઇક્વિલિબ્રિયમમાં you know that કે A plus B plus P that gives C plus C D plus D, that is nothing but the constant. તો constant ને આપણે C raised to C D raised to D એવી રીતે આપણે એને કરી શકીએ. બટ ટૂંકમાં આ તો કયું રાઈટ સાઈડ અને લેફ્ટ સાઈડ. રાઈટ સાઈડ પર આપણે અહીંયા એનોડ લઈએ છીએ અને લેફ્ટ સાઈડ પર કેથોડ લઈએ છીએ. So that's why here the value of anode and cathode. So E cell is equals to E degree cell minus 0.0592 upon n log anode by cathode. This is our idea. So this derivation we have to not do. So that's why you don't bother. Okay. Now final thing is that we are going to check out yourself. So first give the difference between the standard and simple cell potential. So standard cell potential and different cell potential. Standard is always on the temperature 298, pressure 1 and concentration 1. Write the formula to find standard cell potential. So standard cell potential will be derived by E degree cell is equals to E degree cathode minus E degree anode. Okay, that is very simple. What is the value of F in Nernst equation? Value of Nernst is 96500. So now like this very simple questions are there you can give.